Okay, hello everybody. Good evening. Can you all hear me? If you can hear me. Okay, my name is Alexander Manasseh, and I am an AI and robotics educator from Africodes EdTech, and I'm very excited to be with you all this evening. When I got the invite from Benedict, I was just happy to join in and just share with him what we do. And at Africoders, what we do is equip young people and professionals with digital skills in the field of robotics, artificial intelligence, emerging technologies, and digital literacy as a whole. And we do this by arousing people's curiosity, challenging them to think, and also giving them practical lifelong skills that they can use to improve themselves. I look forward to having a great session with the ARC Club this evening, and I hope we can achieve something productive together. Thank you.
Many people in our community are still discovering their path in technology. Could you briefly share what initially inspired you to pursue AI and robotics, and what lessons from your journey would you give to young innovators today?
Okay, thank you for this question. Um, Unlike most people who will tell you they were very passionate about robotics at the start and they wanted to do it, I wasn't actually that way. My journey into robotics started out as a volunteer. I got invited to be a volunteer at the first Lego League National Championship Finals by my friend and my current partner, Mr. Tobo Jerry. His organization at the time was hosting the event. And at the time, I had no prior knowledge of anything about robotics. I did not know anything. I could not write any single line of code. I had never even seen a robot up until that point. And all I had in mind was to go to this event and hand out forms and documents for people to sign. But as God would have it and as fate would have it, I was meant to be an innovative projects and robots design judge. So, and have in mind again, I had no experience. I did not know anything, but I was told I was going to be paired with professionals. Now, on getting to the event, I was quite fascinated by the setup of the whole entire event. And during the process of interviewing students and listening to their project presentations and the concepts and ideas they had about their robots, um, I got to I got to discover that this was what I was supposed to be doing. I was so fascinated, my mind was blown, and I showed interest in learning. And my friend, Mr. Jerry, again opened up their platform for me to get a foundational knowledge of robotics, of programming. And over the years, over the past 10 years, I've been traveling around Nigeria, inspiring young minds, and creating new methods of teaching innovation and robotics, artificial intelligence, and digital literacy that is adapted to helping young people actually apply the skills to improving themselves. And I always say that it's been the joy of my life to teach robotics and artificial intelligence, as I've got to see young people who were just like me, who did not know anything, who were shy, who were timid, could not express themselves, could not write a single line of code, and I've watched them evolve into innovators who can solve problems on their own, who can communicate their ideas with clarity. And this is what I've been doing, and this is how I got into it. And my advice for someone who is interested in learning and joining in is just be grounded, take the time to take the time to understand how things work, take the time to be curious, take the time to ask the right questions, and with that you're already bound to succeed in the field of robotics. Thank you.
From the work that you've done with schools and communities, what strategies have proven most effective in getting young people genuinely interested in robotics? As we had talked earlier, you had mentioned that you deal with students even from high schools, universities. Yeah.
Okay, so I'm in Nigeria, so definitely I'm going to start by telling you a parable or a proverb, brother. Or an adage, as the case may be. You don't start building a house by roofing it. You start building a house by laying foundation. And there are three foundations that are essential to getting young people genuinely interested in robotics. The first I actually make use of is I start by building a connection with my students. Okay, I make it a priority to get to know them and establish a relationship with them. I get to understand their weaknesses, I get to understand their strengths, I get to understand their educational needs, and then adapt to training them that way. I also make it a point to establish trust with them because I understand that when young people are comfortable with you, when they are comfortable and feel seen by you, they are more willing to learn from you. The second thing I do, so in essence, I start by building a human relationship foundation first. And the second thing I do is I teach my students how to think. Mostly because the field of robotics is quite complex and it requires you to think. And it is in your inability to think that you get overwhelmed. It is in your inability to think that you lose interest. And whether you believe it or not, a lot of people have not been taught how to think. So I take it upon myself to teach them how to reason logically first. I take it a step further by teaching them how to think computationally and also in sequence. Because if you can, they have a clarity of thoughts, if there's clarity in how you think, if you can think of providing solutions, making use of calculated steps, you can address problems and break them down to simple forms, making it easier for you to grasp the whole essence of being in the robotics field because it requires you to think and provide solution. So I establish a human-based foundation first, and then a thinking foundation, and lastly, it goes towards um, developing, helping the students work together in teams. The reason I do this is very simple because when you work with only one person, you tend to see the gaps in how they think. You tend to see the flaws in how they work. But in pairing them up together as teams, they get to bond together, they get to share ideas together, they get to sharpen each other's thinking, and it is from sharpening each other's thinking that they get better. And I don't stop there. I also make it a priority to hand out leadership roles to my students to give them a sense of responsibility and commitment. And I do this most especially for the female students. Yes, because female students tend to isolate themselves in technical spaces, but by giving them visible leadership positions and responsibilities, they feel seen, they feel like a part of the group, and they tend to give out more. So, after developing the foundation of a human based relationship and the thinking foundation, I also tend to develop a collaborative foundation for them to work together. And it doesn't end there because if you really want to get students interested, you have to adopt it. You have to adopt a method that is linked to providing hands-on projects based on missions that they can relate to around their environment. The reason is when they can solve problems that they can see around them, they are more interested. And it is why I mostly make them work in teams so that they can share ideas on the problems they see around them and how they can provide solutions to them. This is how I personally get students interested in the field of robotics. Thank you. Yes, with the students getting understanding their weaknesses and their strengths and also their educational needs. Yes. Thank you very much as well. The truth of it is, robotics equipment are expensive. It's just the truth. But for people starting out, for schools, for institutions starting out, you don't necessarily need to get uh, elaborate kits or high end kits. You can literally start with low cost kits and basic tools that can help the students experiment and build. The focus majorly should just be on hands-on problem solving and creative thinking. The rest can always come at a later time. The most important thing is starting, and in starting you just need basic equipment, and you can from there grow. If you really want to make it accessible to everyone, you don't necessarily need to start with hardware. You can literally start with online robotics courses, and it is something that you can build from, pending when you can actually get get in, as in you're in February terms and conditions where you can get the kinds of kits and equipment that you need. But for someone starting out, you just need simple kits, simple programs, and you can even start virtually. So it's that is, if you really want to make it accessible to your students, you can always start simple.
Now let's talk about this. If a student wants to learn robotics today with little or no experience whatsoever, so what are the foundational skills that they should focus on first before diving into this? Yeah.
Okay. When I started out, like I said, I did not know anything. I am not even going to lie about that. But I was very curious. I'm someone who likes asking a lot of questions, and the first thing you need to be able to do is to know how to ask questions. You need to develop the skill of knowing how to ask questions. You need to ask questions about how things work. How can they be done better? What could be improved? Are there other ways of arriving at a particular solution? I started out by asking a lot of questions. I remember when we started, I started working on with Lego robots, and I started working with the EV3 Mindstorm robots. And at the time, the only thing I knew how to build was the what's it called again? The the Riley Rover, but and I always struggled with working on movements, and I kept asking questions on, okay, how can I make my turns precise? How can I grab things with the bots, and how can I add extensions, and how do I program each of them to work? And the second thing you need to develop is a problem solving mindset, because if if you know how to ask questions and you don't know how to provide solutions to the questions you've asked, you're still lacking behind. So you need to be able to ask the right questions and also be able to identify how to solve those problems, and which is why I said there's a need for you to learn how to think, because in problem solving you have to be able to break down problems into simple steps. Yes, if, say for example, now you wake up in the morning and you need to go out to work or to class, and you're a uni student, so you need to go to class. There are steps to be taken in order for you to get to class. You don't just wake up without brushing your teeth, without having a bath, and you just arrive in class. No, you don't do that. So you have to be able to simplify problems, break them down into steps, and provide solutions, which is developing a problem solving mindset. And the last thing is you need basic knowledge of programming. It is not that important because eventually everyone learns as they start, but you need basic knowledge of programming. You need basic understanding of the logic behind how to program. And without that clarity of thought, it is going to be difficult for you to adapt. You're going to be overwhelmed and you're going to struggle. But if you can ask the right questions, if you have the mindset of being able to break down problems into simple steps and sometimes prefer your own solutions, not just waiting to receive answers from other people. And then you have basic programming knowledge of how to transfer those your ideas to practical solutions. You're good to go. Thank you. Yes. 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 How can I make it better? How can I make it better? What can I change to achieve the right result? What needs to be done differently? So these are basically the kind of mindset you need to have when you're coming in. If you're waiting to, this is not like regular ICT where they tell you everything. You have to prefer solutions. In the field of robotics, it is about preferring solutions. It is about asking questions and providing answers to those questions.
Okay. Thanks for that. Now we have this. It's actually, let's say everyone. So, some people believe robotics requires expensive equipment and advanced math. So, because these are challenges in a way. So, how can institutions make AI and robotics more accessible to students despite these challenges?
The truth of it is, robotics equipment are expensive. It's just the truth. But for people starting out, for schools, for institutions starting out, you don't necessarily need to get uh, elaborate kits or high end kits. You can literally start with low cost kits and basic tools that can help the students experiment and build. The focus majorly should just be on hands-on problem solving and creative thinking. The rest can always come at a later time. The most important thing is starting, and in starting you just need basic equipment and you can from there grow. If you really want to make it accessible to everyone, you don't necessarily need to start with hardware. You can literally start with online robotics courses, and it is something that you can build from, pending when you can actually get get in, as in you're in favorable terms and conditions where you can get the kinds of kits and equipment that you need. But for someone starting out, you just need simple kits, simple programs, and you can even start virtually. So it's that is, if you really want to make it accessible to your students, you can always start simple. Well, Um, okay. To be honest, you're already on the right track. I am not even going to lie about that. Webinars and workshops of this nature that you've been putting together is a great start. This way, you get to keep your members engaged. You get to keep them focused on hands-on sessions, and then what you need to do is to just organize build sessions, organize coding sections, and then experiment together as a group. You can even start by organizing small in-house team tournaments just to encourage teamwork, just to encourage problem solving by working on projects. And then you can also engage in hackathons and other external competitions just to learn from each other and to improve the knowledge that you already have. The truth is, in organizing this kind of workshops and webinars, you're creating a space where young minds who are like-minded can think together, can learn, can create and innovate together, and naturally you're going to grow and progress. So I think so sorry about that. My network got disconnected. So yes, like I was saying, all you need build sessions, organize more in-house tournaments, and then participate in hackathons, and then try out solving projects and problems around you. This way, you get to grow together and you get to maintain the spirit of innovation within the club.
Aha. Okay, thanks for that. So, how important are robotics competitions, hackathons, and collaborative projects in shaping a student's learning journey? Because what I believe is that these events they try to just teach you something that you won't learn in a class, basically. So, like, how important are they?
Uh, okay. To be very honest with you, I'm not going to lie to you. They are extremely valuable. Yes, because for a club, it creates a sense of purpose and challenge. And these competitions, these hackathons, they give students valuable exposure. And it is in this exposure that they get to actually see how they think themselves and how they approach problems. And it also it reveals the depth of knowledge that they have. They get to also see how other people think, how other people approach problems from other cultures, and then provides an opportunity for students to test their own ideas, for them to learn from others and see problems in a different way. These experiences are very valuable because it helps people see the practical understanding involved in robotics, and then it builds teamwork, creativity, and confidence as a whole. They are like, I'll tell you one small treat. I get to sign up a whole lot of my students for hackathons. I register them for tournaments, and when they go out and they see how other people solve problems with different builds, different than the one that they did themselves, they are amazed. They also get to test how knowledgeable they are. They get to see how well and it even builds confidence in them to a very large extent because they get to understand different dynamics and different methods approach in solving problems. There could be a central team related to, say, for example, now, okay, there's a hackathon my students are currently participating in Egypt called the STEAM Pathway Hackathon, and the solutions they were meant to provide for the projects and models they were to build were related to SDG goals, and then so many people chose to work on I think is it water something, water purification or something, or conservation or cleanliness, something related to water, and they all brought came up with similar ideas, but there was a difference in how they addressed those problems. There's also a difference in how they built their models and explained their solution. So these tournaments get to test them, gets to check how intellectually sound they are, how well they understand concepts, and how well they get to work together as teams. So it's a very valuable experience and exposure, and this is what helps clubs and communities build robotics-based communities of this kind to thrive. So it's very important that students get the exposure to compete with their peers and just get valuable knowledge and experience.
Okay. The last time that we had talked, you mentioned to me that during last year you were able to send some of your students from Aficodas to represent Nigeria in a robotics competition in Switzerland. I would like us to arrange a session in the future where the student can tell us about the experience in events like that. So, what do you think? And by the way, I believe that will be very essential to us because we'll get now the first-hand information like how the event was, how it helped them to what they learned as well. Yeah, it will just be meaningful. Uh,
Okay, not a problem. It's something that we can arrange. Um, like I said, it's an exciting field. You see students getting to see how other people's culture um, is. You see students from places that they did not know they could get to, and then they get to experience a different kind of reality, different from the one they are used to. They they get to see, and there's this funny thing about young Africans. We always tend to be inferior when we meet with foreigners. But I think I think from this last one, I noticed that a lot of our students are not even inferior in thinking. What they just lack is opportunity, and these kinds of opportunities to participate in tournaments, it boosts confidence in them a lot. It helps them to sharpen their thinking, and they know that a lot is possible, a lot can be achieved by them regardless of where they are from and their background.
okay. What type of beginner projects would you recommend for students who want to build practical experience in AI and robotics? Yeah, basically for the students who are just starting out. Yeah, which ones are the best?
So in the field of robotics, the major problems are obstacle avoidance and line following, which are where every beginner starts from. You have to be able to follow lines. You can start from line following projects and in-house tournaments where teams can compete against each other for first to finish the course on time, and which team is going to do it more accurately. And then that's for line following and for obstacle avoidance. Also, you can decide to start by working on projects around you, like providing solutions to projects around you. I see a lot of videos from Kenya and East Africa where there are different kinds of people coming up with different types of solutions, but some of them are quite advanced. I think I saw a project the other day on TikTok where someone built a drone that is used for planting. So what it does, it disperses seeds on a farmland. But this is way advanced and requires a whole lot of know-how for people starting out. The basic is to learn basic life following projects, obstacle avoidance courses, different kinds. You can make designs of any kind. Then you could also, like again, you could also work on projects related to you, say a waste bin that identifies motion, or a radar or a heat sensor projects. These are basic projects that you can start up with, making use of simple Arduino kits and simple robotics kits as like that as well.
Yeah, thanks for watching the part one. So part two will come up later on. It won't take much time, possibly before the end of the week or the beginning of next week. So what to expect in the part two? The first one is what differentiates successful students in AI and robotics from those who struggle to progress in this field. That is one of them. Then we'll have an understanding of some key technical concepts, for example, machine learning, computer vision, reinforcement learning. You'll just learn about them in the next one. Then you learn how universities, startups, or organizations can collaborate to build a stronger AI and robotics ecosystem because it needs to be there. Yeah, the strong AI and robotics ecosystem, more so here in Africa. Then you'll get to know the perspective of the speaker concerning the future of AI and robotics. So stay tuned for part two. I hope you enjoy this. You can hit the like button, share, subscribe, and comment. Actually, comment so that we can know how better to handle these webinars. Yeah. Thanks so much for watching, and we meet in part 2. Thank you. Bye bye.